Hello, for today's guided learning, we're going to work on learning target 1.2, or distinguishing between English and metric systems. First we have to define, then we have to be able to identify common units, then we'll finally be able to convert between the units of the metric and English system. This is known as dimensional analysis. This will help us and lead us up to our end focus question of how does an object's speed and acceleration affect its motion. Take a couple minutes and read defining the metric system. We're going to start by converting metric units to metric units. First, we need to be able to identify the common units of the metric system. You may have heard of these before. Kilometer, centimeter, millimeter, milliliter. Alright? The metric system is based on a base unit, and that is our most important unit. Alright? We start with grams, liters, and meters. I use a mnemonic device to help me remember the prefixes. King Henry died by drinking chocolate milk. King Henry died by drinking chocolate milk. Each letter stands for a prefix. A prefix indicates the value of that number. So King stands for kilo, Henry stands for hecto, and so on. Now, if you move to the right of the base, the numbers get smaller. If you move to the left of the base unit, the numbers get bigger. So if we start in our base unit, call that 1, a kilogram is 1,000, you would multiply it by 1,000 times. Alright? That means it's 1,000 times bigger than the gram. But a milligram is 1,000 times smaller than the gram. This organizer right here will help you in converting between the metric units. I want you to pause for a second and practice the mnemonic device so we can remember the prefixes. Procedure number 1 for converting between the units of the metric system. We first need to start by identifying the starting prefix, then we need to identify the ending prefix, then we need to place number and decimal point at starting prefix in graphic organizer, then finally we will loop the decimal point to the ending prefix and add zeros if we need. So let's begin. Identify the starting unit. How many centigrams are there in 24 grams? So our starting unit is grams. Identify the ending unit. How many centigrams? So our ending unit is centigrams. Place the number and decimal point at the starting prefix in the graphic organizer. This is already done for us. 24. And look at our decimal point. It's at the base value. Loop the decimal point to the ending prefixes and add zeros if needed. So I'm going to loop it over. 1, 2. It needs to be to the right of the number. I have empty loop-de-loops, so I have to add zeros. So, how many grams are there? How many centigrams are there in a gram? Well, there's 2,400 centigrams. Let's try another one. Step 1. Identify the starting prefixes. How many grams are there? So I'll identify my starting prefix as grams. Then you need to identify the ending prefixes, and it's going to ask for kilograms. So I'm moving all the way over here. Place number, which is already done, and then loop. 1, 2, 3. Place my decimal point there, and add zeros to any empty loop-de-loops. So, how many kilograms are there in 24 grams? Well, there is 0.024 grams. I now want you to pause and do problems 1 through 8 in the student practice section. Remember, you can go back to the video to help you understand or help you through those practice problems. Now there's a second procedure for converting. I call this the T-up procedure, or the picket fence procedure. Here are the steps. Take a minute and look at those steps. Example, how many centigrams are there in 24 grams? I'm using this to show you that you can use either procedure to convert between metric units. So we restate the question, 24 grams equals blank centigrams. It tells us to identify the starting unit, which is grams, identify the ending prefix, which is centigrams. All right, then select your conversion factor, and here's our conversion factor. 1 gram equals 100 centigrams. Then we need to tee up the values, so I draw a big T. I need to crisscross my unit, but I'm going to place my starting values, or starting prefix, in the upper corner, so 24 grams. Now we need to crisscross the T'd unit, and we place our conversion factor in the T, and now we multiply or divide. So what this stands for is 24 grams times, if it's on the same level, this is on the same level, we multiply 100 centigrams divided by 1 gram. That would equal 2,400 centigrams. Let's try another one. Identify the starting prefix. How many kilograms are there in 24 grams? So we're going to identify the starting prefix, which is grams. Identify the ending prefix. How many kilograms are there? Select our conversion factor. 1,000 grams equals 1 kilogram. Step 4, tee up the values. Remember, our starting unit always goes in the upper left-hand box. So our starting number is 24 grams. Step 5 tells us to crisscross our unit. So now we need to place our conversion factor with proper units in the T. So gram is down here. So I'll write 1,000 grams. Our conversion factor is 1 to 1 gram, or 1 kilogram. Now we will multiply or divide. So we place the units on top together, and we multiply those units. So 24 grams times 1 kilogram. And then we divide, if it's on bottom, 1,000 grams. So I'm going to take 24 times 1 divided by 1,000, and that will equal 0.024 kilograms. Our units cancel out because they're on bottom. Alright, now I need you to pause the video and do problems 9 through 15 in the student practice section. Remember, you can always go back and watch the process again. Email me if you have any questions. Thank you.